All right, today we're talking about tangents and normals, which is an application of the derivative. A tangent, just to go back to your regular definition of what a tangent is, that is a line that touches the curve at a point so that the line slope represents the instantaneous rate of change of the curve's function at that point. So you can see how this curve has a certain slope, and if that slope were to stay the same, going to the left and to the right, it would create this red line here, which is a tangent line to the curve. So we're going to start there, and then it's an easy switch to get to the normal. So we're going to do an example. F of x is going to equal x squared minus 2x plus 1, and we're going to look specifically at what the tangent line looks like at x equals 2. Well, the first thing I want to know is what's the y-coordinate on the curve at x equals 2, because that's also going to be the y-coordinate on the tangent line, since the two are going to touch there. So what I do is I take x equals 2 and I plug it into my function, and I get a y value of 1. So that means that the curve and the tangent line are going to touch each other at the point where x is 2 and y is 1. So that's the first thing I need to do. And the second thing I need to do is figure out what the slope of that line is going to be. And to do that, we know that we're going to have to take the derivative. So I go back up to my f of x, figure out what f prime is going to be, and that's going to be 2x minus 2. And I only need to plug in my x value to figure out what the slope is. So I plug in my x value of 2. And I find that the derivative is 2, which means that the slope of the tangent line is also 2. So that means that the line is going to pass through 2 and 1, and it's going to have a slope of 2. So using point slope form, I know that the equation of the line is going to be y minus 1 equals 2 times x minus 2. All right. And then to get from the tangent to the normal, all I need to know is that the normal line is going to be perpendicular to the tangent line at any point. So I could go through the same process, figure out what the y value is, figure out what the derivative is, which would give me the slope of the tangent line, and then I just need to take the negative reciprocal of that slope to get the slope of the normal line. So if the slope of the tangent line is 2, that means that the slope of the normal line is negative a half. Everything else is the same, so the equation of the normal line would be y minus 1 equals negative a half times x minus 2. And just to give you an idea of what that looks like, here is a picture of what I've just done. Here is the curve f of x, and then in red there is the tangent line touching at 2, 1. And so it's kind of representing what the slope of the curve is at the same time. And then perpendicular to that is the normal line, which has this equation right here. So that just kind of gives you an idea of one minor application of the derivative to find the tangent line and the normal line at any given point.